So what was happening in the last lesson? Let me quickly move that up to the side there. So in the last lesson, we spoke about really big numbers. And we spoke about, let me just move this down. We spoke about, say, like a number like, let's say, 300,000. Now that's not even that big a number. Maybe we'll make it even bigger. We'll make it 300 million. And what we said was, if we want to write this without the zeros, we use something called scientific notation. And what we do in scientific notation is we first ask ourselves, can we move the decimal point? Okay, can we move it all the way? Let's see if we've got a different color here to make it easier. Oh, green. Can we move that decimal point all the way to the front where it only has one number in front? And we're going to count 1, 2, 3, 4, 5, 6, 7, 8. So we're going to rewrite this number with the decimal point over here. So 3.0, for lack of a better word. Now 3 is not the same as 300 million. But what we figured out is that we could, for each jump over a 0, it represented a multiplication of 10. And so all we needed to do was write down 3.0, or 3 times 10 to the power of however many jumps we jumped over. So it was 8 in this case. So that's 3.0 times 10 to the 8. So that was the basic translation from a big number into scientific notation. Give me a thumbs up if you feel like you're okay with that part. Give me a thumbs up in the chat if you feel like you remember the last lesson and it feels good. Okay, awesome. So today's lesson is going to be moving from the one end of the scale, the really big number, to a really small number. So if I look in the last lesson, we left off at this point, and the type of question that is a big number is this one over here. And the decimal point would be at the end here. But some of these numbers are actually really small. And so how do we write that? And so I want to do one example with you, and then I want you to try and do one for me. But let's look at the process. Now, whenever we write something in scientific notation, we always want the decimal point to be in front of just one number. So in 1.4, we recognize this is a very small number because of all these zeros, 0.000 and so on. What we want is to move this decimal point from here, 1, 2, 3, 4, 5. Okay, so let's start with this, where we go 6.0, well, 6.0, let me write it in a different depth, 6.05. Now, if I stopped at that point, I would be telling a lie, because 0.000 and so on, small number, is not equal to 6.05. So what do we need to do in order to balance this out, but still use the same type of idea? Well, what do you think we need to do? I'd love you to put something in the chat. What needs to happen in order for these two numbers to be equal? Do I need to make 6.05 bigger? Or do I need to make 6.05 smaller? Or I'd love to hear in the chat, or maybe if somebody could raise their hand. What do you think we need to do in order to make the small number equivalent to this thing on the right-hand side? Tando, I see your hand. What do you have to tell us?
I'm not quite sure, but I think we have to move 5 steps to the right, because we moved from the zeros and we went to the 6.05. So I'm guessing we have to move to the right.
Okay, you are definitely most of the way there. So the number of jumps really, really matters. And you're right that we counted 1, 2, 3, 4, 5 jumps. But the difference, if we had to write it like this, okay, if we wrote it like that, that would make the number even bigger. And we don't want that. We know that this number is very, very small. And so because it's very, very small, the 6.05 actually has to get smaller. And so what we're going to do is we're not going to times by 10 to the power of 5. We're going to divide it by 10 to the power of 5. Now, just take a moment to think about that. Now, 10 to the power of 5 is the number 100,000, but all I did to get my 5s was I counted how many jumps I did. Okay, so that's step one. The step one is I'm not timesing by 10 to the 5 anymore. I'm now dividing because it's a very small number. However, this doesn't look very nice. So how do I make it look like scientific notation, nice and neat? Now, there's another little clever thing about exponents that some of you may not know. And I'm going to just show you this little trick. So if you have 1 over 10 to the power of 5, that is the same if I bring this thing at the bottom, if I bring it up above, it becomes 10 to the power of minus 5. So if you write times 10 to the power of minus 5, it's the same as dividing by 10 to the power of 5. So because that is true, so basically the way students often think about it is if it goes from below the line to above the line, it changes from a positive to a negative. So what that means here is I write 6.05 times 10 to the minus 5. And that is what we call scientific notation for a very small number. So I want to go through the steps again. So the first step was I asked myself, what do I need to do to get the decimal point from here all the way to in front of the 6? And then I wrote down this number over here. Now, the only thing that's different from before, really, if you look at it, is instead of writing times 10, if I'd written times 10 to the power of 5, that would have been wrong. What I really want to do is just write it as a negative power. And if I write it as a negative power, what that's doing, it's taking this number and it's dividing it by whatever number of jumps I've done. Okay, so it sounds a bit weird, but it's really, really not that bad. And so the main thing that I'm left with is if you have a small number, you're going to end up with a negative power. That's something to watch out for. Otherwise, it's almost the same as before. So what I want now is I want everybody to try and write 1.5 in scientific notation. Okay, so just give it your best bet or your best go and try and do 1.5 in scientific notation, but realize that 1.5 is a very small number. Okay, so over to you guys.
Let's do this, guys. Woo. We can do it. I see. This is the one we need. Iminati is like, sir, I'm giving you an answer. Let's see more.
So I definitely think I'm going to start by writing 6.0 as the first part of my scientific notation, or 6. And then what's the next part going to be? So be careful. If I wrote, there were 3 jumps, 1, 2, 3. If there were 3 jumps, if I wrote times 10 to the 3, that is taking 6 and timesing it by 1,000, which means that I'm saying the number is 6,000, which it's not. So I need, because it's a small number, it needs to be a negative power. And so that will be the answer to 1.5. So whenever you see that negative power, what it means is it's taking the thing at the beginning and it's dividing it by however many jumps of 10 that we've done. Okay, let's do another one. Let's do 1.6. I want everybody to try and write 1.6 in scientific notation.
Well done, my people. You guys did well.
Yep. I see. Yeah.
Those of you that forgot the minus, remember that it's important as Teacher Peter is telling us, okay? So just do some corrections on your work like this, you don't forget it.
I'll give you a moment to see who can get 1.6. And this one's 1.5, 1.6. So remember, with scientific notation, we always only want one number in front of the decimal point, and we want that number to be between essentially 1 and 9. So let's see this dot. 1, 2, 3. So I think I'm going to start with that. But if I left it, I'd be wrong. So what do I need to do now? 2, 3. I see Mike has got an answer that they've put in. Who else has an answer for this one? Valela. Okay. So you're quite right. Because it's a very small number, all I need to do is write times 10. And again, it's going to be to the power of -3. I see Theo's got an answer, and that is fantastic. All right, Kendra, same thing. Okay, so guys, if you need more time on this, take a screenshot at this moment, but I'm going to move on to some more questions now, because it seems to me like most of us are feeling kind of okay about this, but I could be wrong. So if I am, let me know in the chat.
Remember, when you're lost, you're always welcome to raise your hand, and I hope you did take your screenshots.
Okay, now this next one is going to be a multiple choice question. And so the options are going to be, let's have a look here. I'm going to call this one A, this one B, this one C, and this one D. And I want you to tell me which of these options is the correct way to write this number in scientific notation. Now, they all look kind of similar, so you have to look carefully which is going to be the correct one. And again, it's a very small number. And so it would be such a mission to write all those zeros. We really need a quicker, more efficient way of writing that. Okay, so let's see what's going on in the chat. There's a couple of different options going on. The first thing I do is I always make sure I can count 1, 2, 3, 4, 6, 7, 8. So I get 4.25 to start with, because that's the initial part of my scientific notation. And then I have to ask myself how many jumps I jumped over, or I can count. Wait, let's see. What is the chat saying mostly at the moment? Okay, well, 1, 2, 3, 4, 5, 6, 7, 8. It looks to me like 8 jumps, which means it must be 10 to the power of -8. Is there one like that? It's going to be C over here.
Yay. Well done, my people. So we were debating on the chart whether it was C or D.
Yeah, I'm glad they knew that, because they knew that it couldn't be A or D because it doesn't have the correct first number for the scientific notation. Okay, let's keep the show on the road. I want you to do 2 of these now. Let's put both questions up. So we'll call this, we'll just call this one A and this one B. I want you guys to write these in scientific notation for me. And then once you've got these 2, I think we're ready for mixed examples.
Let's go, my people. We're doing this. We are on fire today.
I promised them that we'd make the zeros disappear. And you can see that by learning to write like this, it really does allow you to talk about really big things and really small things in an efficient way. And later on in science, they talk about like orders of magnitude and these types of ideas, which all build into scientific notation. Let me see what I would start with. 1, 2, 3, 4. So I would get to that point. And then I know it's a very small number because of the zeros in front of the, well, behind the decimal point. And so I'm going to get 4.1 times 10 to the minus 4 for that one. Now, what about the second one? B. I see Laseri's got an answer coming through.
It's you guys are doing well.
Tando, yeah. So again, 1, 2, 3, 4, 5, 6. And because it is a very small number, again, I have to emphasize this, whenever there's a small number, there's going to be a negative power. And in this case, I jumped over 6. So each time the decimal point moves, it's basically one power of 10, or it's either a multiplication or division. In this case, it's going to be negative because we know that 3.45 is bigger than the number we started with. And so this bit at the end has to make sure it's on the right size. Okay, so we get 3.45 times 10 to the minus 6. So I think you guys are comfortable now with writing really small numbers. And we've done big ones, so I think it's time that we mix them together. And so take a screenshot if you need to. Those are the correct answers. Aganati, I see that answer there. Fantastic. Let me go to a mixed question now. So you guys are going to write the following 5 numbers in scientific notation for me. Now, just to clarify, the commas are not decimal points. In this case over here, the commas are just an American way of separating out the digits. But in this number, the decimal point is at the end of the number. So the decimal point is here, and the decimal point is there. It's obvious in this one, it's there, and it's there. So over to you.
Would that be okay, Teacher Peter, if you could write it next to it, like the number, how it's supposed to be?
So normally, yeah, the other way of writing the number would be like this. And we normally tend to write numbers in groups of 3 digits. So this is the same way of writing that. It means the same thing. It's just a formatting. This is the same as 796, 1,000 there. But what I want from you is I want it written in scientific notation. And so over to you guys. And there's a mixture of big and small numbers here. So be careful because that's going to affect things.
Ooh.
But I'm not saying more than that.
Spicy. I see Lish there with question 1. She's done. Let's see other people's answers. Let's do it, guys. You guys are doing great.
If there are students who would like to discuss something, now is a good time because obviously lots of students are working on these problems, but there's a bit of time for us to just talk about if there's something maybe you've missed. So think about the chat or maybe even raising your hand. That could be fun. I see Lichle's answer coming through. I see Theo's answer.
Theo, just remember to label them, okay? Label them 1, 2, 3, so we can see.
So the very first one is going to be that, and that's what I see Iminati got and what Kendra got, Lasedi got. So that's the first one. Now, what about the second, third, fourth, and fifth one?
Ooh, please mark your work. Teacher Peter, how many marks would we get for this if we're in class?
You know, I think this is probably a 1 mark question, to be honest. Maybe a 2 mark. So maybe what you could do is you could have had a mark for the the significant or the thing in front, and then a mark for the powers of 10 over here. It depends. I've seen both used.
Hey guys, I hope we are marking, okay? Because we're not going to lose these marks in the exam.
Okay. So Andile, can't understand question 4 and 5. So question 4 and 5, Andile, is I just want you to think the decimal point is now in front, just behind the 2 and just behind the 0. We would really like them to be further to the left, those decimal points, in order to be written in scientific notation form. So what can you do to move that decimal point in that direction? That's what I'm going to kind of say. Now, in this one, the decimal point is over here. So we go 1, 2, 3, oh, 4, 5, 6, 7, 8, 9. So I get 2.0 or 2 times 10. And because it's a big number, I'm not going to have a negative power. I have a positive power. So that's the big difference. I really want to emphasize that. Small numbers have negative powers. Big numbers have positive powers. Because, and it kind of makes sense. If I said 2 billion is the same as 2, you'd go, no, it's not. You're lying. So we need the extra bit at the end to make the number even bigger. But as scientists, we really like to be able to see the number separated out like this. Okay, so 2.0 times 10 to the 9. Okay, what about the next one? See, Micah's got something that in the chats. Jabu has had a go at question 4 as well. Kendra's also got a go at question 3. Looks like a big number to me. So 7.96. So 5 times 10 to the positive 5.
Please correct your work. I do see some answers there that have some errors there and there. So please do correct your work. And if you don't understand, you are more than welcome to raise your hand. Like this, Teacher Peter can explain to us, okay? So 872 and 90, you may say, well, why do I even have to write that in scientific notation? That's a normal type of number. It is, but sometimes we are, if everybody is using scientific notation, we kind of want all numbers to be able to fit into that pattern if we need to. So we still need to know how to do it. And here we just have to jump twice. So we get 8.72 times 10 to the power of 2. And so that's number 4. So watch out there. If you got 3, you've jumped too far, because remember, you have to store, it's over here, and you have to go, you have to leave one number in front of the decimal point. And then the last one, 90, I'm just going to do one. Amandla is on the line, so I'm just going to send her to you.
Perfect, no problem. Go ahead.
Hi, so how did you get 7.96 times 10 to the power of 5? Because there's only 3 zeros.
Okay, the important bit is when I started my journey, I jumped over the first 0, and then I jumped over the second one, the third one. But you know what? The decimal point can jump over the 6 as well. And that is still basically a power of 10. And when it can jump over the 9 as well. So even though it's jumped over zeros, it's not just jumping over zeros that is a multiplication of 10. It's anytime we move one jump to the left, and so we jump over the 6 and the 9. So does that help a little bit?
Yeah, thank you.
Pleasure, man. Pleasure, pleasure. Okay, so that is a mixture of big and small numbers. And so take a moment to mark your work. And then I think what we're going to do is we are going to have our brain break at this point and a little stretch.
Tando
But
is on the line. So I think we're getting all the questions now. I don't know. Can I
that's
let them?
fine. Yeah, let them in. Hi, Tando.
Sir,
Yes.
with question 5, is it
Yes.
a problem? Is it wrong if it's 9.0?
No, it's completely fine. So 9.0 is exactly the same as 9. And so that's perfectly fine.
Okay.
It's equivalent. Yeah. And then Kanyisile?
Hi, sir. So is
Hey.
it fine if for question 5 I left it as 9,0 times 10 without the 1?
That's also fine. Yeah, because the moment, so look, you would generally, in scientific notation, we do like to see the power. So I would say, please put it in if you can, but the fact that you left it out, the assumption is 1, so you're not wrong. Yeah. But I would say generally you would put the power in with scientific notation. All right, I want everyone on their feet and I want a little stretch. So let's stand up and I'm going to do a calf stretch. And I want to see who's got the best stretching technique. And Yolanda, if you can help me in my search, maybe we can find the next Virgin Active best instructor.
Definitely.
Talent search on Watobe.
Definitely. I am searching. I see Kendra, Iminati. Oh, Chantal, go. Let's do the stretch. Let's do this. Lawrence, I cannot see a stretch. Chantal was really focusing on writing answers down.
Let's
do this, guys.
For a little stretch. It really will. So have a little stretch. You're never too old or too young to stretch, I promise.
Yeah, always let's go. Let's go, always. Let's go. Let's go, girl.
And then
Bulela, are you stretching?
There we go.
Thank you, my people.
All right, fantastic. Now that your brains have had a little bit of oxygen, a little blood, why don't you come back to this brain break riddle? Let's have a look. So there's YouTube, Facebook, and Instagram. And I want to know what is, all right. What is this going to be equal to? People know what YouTube is. People know what YouTube is.
Remember this, I always have some tricks within
I do
you.
always have a little something.
Yeah, you always have tricks. So be careful, be careful.
Okay, so you're right. I agree that these are going to be 7. But now we have to kind of know our times tables to help us with figuring out this bit. So we need to think, what is our 7 times tables and what number times this plus this? So I'm thinking like, what about 8 or 9 or 10 or somewhere around there? So I think, yes, I see the answers coming through. So, you know, like if I put a 3 there, it would be way too small. If I put a 6, still a bit small. I think it's got to be a number that's a bit bigger. And I see some of you are getting in the chat. Yes, 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 yes. So this is going to be a 9. However, we still need to deal with Instagram. Yes, I see people have got it. It's 9 for Facebook. Now, what about Instagram? So something times 9 plus that same something equals 80. What's that going to be? So this, it really helps to know your times tables, doesn't it? Again, it can't really be a 3 or 4. It has to be a bigger number. And so if I go 7 times 9, 63 plus, no, okay, that will be still too small. it seems like it's 8. Yes. Okay, so this is 8 times 9 is 72 plus 8 is 80. Let me use a different color because it's a bit light. So that's 8. So what is our final answer going to be? Remembering that BODMAS says that multiplication comes before addition. So 9 times 8. And then is that the answer? No. Have a look. I'll wait a moment or two more. So I think that this bit here, 9 times 8 is 72, but I still need to worry about that bit over there, which means, and I see it in the chat now, the final answer is 79. Okay, well done, everyone. We're definitely getting quicker at these. I definitely noticed that we are speeding up, and it's a great way for us to just keep learning our times tables and mental multiplication.
Yeah, definitely.
All right, well done, everyone. That was nice. Okay, let's do one last set of questions on this, except we're going to have a few sneaky things coming in here. So I will help you, or maybe I shouldn't help you. Let's do, I want everyone to try and do number 6, just number 6, and see how you go with that. Think about, it's already written in something a little bit like scientific notation, but it's not exactly. And I want to see who can get the answer to number 6. And then after that, when we've marked number 6, we'll then move on to these 3.
I see Chantal is busy writing. You go, girl. Faith, I see you over there. I see you. Let's write the answer down.
But now remember, guys, sorry, I should have said this. We're writing this in scientific notation. So you're right. This is the same as 27,000. But 27,000 is not in scientific notation. So I do like that it's 27,000, but how would I write it in scientific notation? That's what I'm asking. So sorry, I was a bit vague there. All the questions today are about scientific notation. Be careful. It's not 27 times 10 to the 3. And it's not 2.7 times 10 to the 3 either. Think about it. Think about it for a moment. What happens, and I want you to think about this, the decimal point at the moment is over here. And I don't want 27. What I'd really like is I would really like 2.7. But I can't just change 27 into 2.7. I have to make some adjustments. So think about, how would you write 27 as in scientific notation? Wouldn't you write it as 2.7 times 10 to the power of 1? But then you've got this leftover times 10 to the 3. Now, what you need to think about is, can you combine these two parts together and then write it as a final thing for me? So I want you to take this little bit, and what's the final right answer for 6 going to be? It's going to be 2.7 times 10 to the power of what? Yes, Rebecca, I see that answer. Who else? So notice how when you put these two together, when you've got 10 to the 1 times 10 to the 3, you've got 10 to the 4. Okay. So that was a little bit tricky one. See if you can do number 7 now for me. You just have to think, what is the process we used last time? And then what is the, you can write it as 28,100 normal, but if you think about it, you don't even have to do that, but you can do it as an intermediate step. But what I'm really interested in is, where is the decimal point? And it's hiding over here. So if you want, you can write out the full number, but remember, guys, in this question, what I'm after is not the full number. I want it written in scientific notation. So we still need to do a bit more work there. There we go. So I see in the chat, someone has 2.81. We're definitely going to have 2.81 because the decimal point is going to move to there. But now the big question is, this is a big number. So that's the thing. It's a big number for sure. But what is going to be the power of 10 that I need to end up with at the end there? So I think it means putting these two things together. And so you're going to end up with 2.81 times 10 to the power of 4. Because this bit, where's my thing now? Like this bit over here is handled by that part. And then you just have to work with that, the extra bit in the end, and put them together. All right, last question for now, because I need to explain some stuff to you about the quiz. Let's finish today with our questions with question 8. And I want you to write question 8 in scientific notation. Let's see if you can do that. How would you write question 8 in scientific notation?
We can do this, guys. I already see Tando with an answer. Remember that everyone is marking.
So I think I want to get my decimal point from here to here. And so I know part of the answer is going to look like that. But now I need to think about this. What was the part that gets added on to balance it out? Because number 8 is not the same as 1.79. There's an extra bit that needs to be included. So I'm going to ask you to count how many jumps did I have to do? 1, 2, 3 jumps. But now the question is, what do those 3 jumps actually mean? So think about that for a moment. You've got to the 1.79. You know that there's going to be a 10 times 10. But now what is the power going to be? So I see a lot of students are saying 4, but I disagree, guys, because when I count, let's do this together again. When I go from over here, I jump over that, I jump over that, I jump over that. I've only jumped 3 times. So that's how I got this thing over here. But remember, number 8 is not a very big number. Number 8 to me looks like a very small number, 0.00179. So what I'm going to do is I'm going to have a 3 here, but it's not just going to be a 3, it's going to be a -3. Okay. Let's do number 9 as well, just to make sure we've got this. So number 9, I want you guys we'll finish with number 9, and then we'll go on to talking about the quiz. But I just want to make sure you've absolutely got this, because today's lesson was mostly about being able to write really small numbers in scientific notation. And then there was a bit of mixture, but I want to feel all my students have got this.
We are doing
So that part's quite easy.
I
Yeah.
see.
Yeah. Okay. So it looks to me like everyone is happy that these are at -5. All right. Well done, everyone. That was really great. So just remember, whenever we write something in scientific notation, it just gives us a way of writing numbers very quickly that are very big or very small. The main idea is that the decimal point always has to move so that you only have one number in front of it. And then you have this times 10 part. And the times 10 part will be a positive power if it's big. It'll be a negative power if it's small. And then to get the number, you just have to count how many times or the decimal point has moved. And that's it. And you just practice and you will get there. All right. So